Hello, sir.
Yeah, hello,
Good
Ishan.
evening.
Yeah, good evening, Ishan.
Yes, sir.
Do you remember what topic did we start?
Sir, last class we have started motion in a plane, sir, about vectors and also.
Okay, so
Yes,
we started with motion in a plane.
yes, sir.
Okay, so we can do the questions from that. Just 1 minute. So just now I'm sharing the screen to do questions from there.
Yes, sir. Sir,
Yes.
sir, can you wait 2 minutes, sir? I'll be
Okay,
back,
sure.
sir.
Okay, sure, no issues.
Yes, sir, you can start.
So we have question here. Velocity and acceleration of particle at a time t equal to 0 are u equals to I cap plus 3 j cap meter per second. And acceleration is 4 I cap plus 2 j cap meter per second, respectively. Find the velocity and displacement of the particle at t equals to 2 seconds.
Yes, sir.
So, how will we find out the velocity and the displacement at t equals to 2 seconds? So, this is a real question from occasion. I'm resharing this screen.
Yes, sir.
So, here this is the question.
Sir, sir, to
Okay,
find
are you able?
velocity.
Okay, are you able to get it?
Yes, sir.
Okay. So, okay, just explain me what all information is given here.
Sir, it's given U, sir, and A.
Okay.
And
So how
have to
do I
find,
use it to find out the velocity?
sir, by Vx I cap plus Vy j cap
Okay.
to find velocity, sir.
Okay, obtain the value of velocity
Yes, sir.
at t equals to 2 seconds. And then obtain the displacement at t equals to 2 seconds. Okay, shall I explain this to you, Ishan?
Yes, sir.
Okay, see. The initial velocity, u means the initial velocity. So you are given here the initial velocity u as 2I cap plus 3j cap. So I will be writing my velocity along the x direction to be 2 meter per second and velocity along the y direction to be 3 meter per second.
Yes,
This is
sir.
what it means.
Yes, sir.
Okay. And value of acceleration given. I know the acceleration along the x-axis is given to be 4 meter per second square. Okay. And acceleration along the y-axis is given to be 2 meter per second square.
Yes, sir.
Right?
Yes, sir.
Okay. So now you will be getting here. From this you can obtain, we know the time taken, it's given as 2 seconds. So you have to find the velocity of the particle at t equals to 2 seconds. So can I find the velocity along the x direction by using v equals to u plus at?
Yes, sir.
Okay. So we'll be using the velocity along the x direction was 2 plus acceleration along x is 4 and multiplied time is 2. So we get velocity along the x-axis to be 10 meter per second.
2x. Yes, sir.
In the same way, can you find the velocity along the y direction now?
Yes, sir.
Find the velocity along the y direction. Yeah, what is the velocity along the y direction?
Yes, sir. I'm doing, sir. Sir,
Again, in the same way, you will use the velocity. Yeah,
sir, I'm getting 7, sir.
yes, it's correct. So
Yes, sir.
velocity along the y direction is 7 meter per second. Now, can
Yes,
you
sir.
write this velocity in the form of vectors? I want the
Yes,
velocity vector v. Okay.
yes, sir.
So can I write it as 10 I cap plus 7 j cap?
7. Yes, sir.
Okay.
Yes.
Got it now?
Yes, sir.
Now, in the same way, find out the displacement along the x direction, displacement along the y direction. Find
Okay,
it.
sir.
Using the velocity of the x, find the displacement along x. Using the velocity along y, find the displacement along y.
Sir,
Yes.
sir, to find displacement, we have to use V equal to U plus AT only, sir.
No, no, no. You can use this. How can you find the displacement using this equation?
Ah, yes,
You
sir.
need to use the second equation of motion, s equals to ut plus half at square,
Yes,
or
sir.
you need to use the third equation of motion.
Okay, sir. Sir,
Yeah.
sir, I'm getting 47 by 8, sir.
Hmm?
47 by
For displacement, okay, displacement along the x, you are getting
47 by 8.
okay 2 into 2 plus 1 by 2 multiply acceleration 4 multiply 2 squared, right?
Yes, sir.
So this you are getting 4 plus we get 2, so it's
Sir, I used
8.
the third equation, sir.
Which one?
Third equation I used. V square minus
If
U square equals to S.
okay, so even if you use the third equation, I think then also you should be getting okay.
Sir, voice is breaking, sir.
It should not. Now I don't think it should break. Just let me check my speed. I think it
Yes, sir.
should be okay. No, I'm having a good speed. Okay, so maybe in between it might have gone wrong. Okay,
Okay, sir. Yes, sir.
so here I'm getting 12 meter as the displacement by this method. Now,
Okay,
if you
sir.
use v squared minus u squared, so let's try to use v squared minus u squared. So you get 10 squared minus u is 2 squared equals to 2 multiply acceleration is 4 multiply s, that is displacement. So this will be equal to 100 minus 4. 100 minus 4 is 96, and you get 96 divided by 8 to be equal to the displacement. Now divide 96 by 8. Are you not getting 12?
Sir, I'm doing again, sir.
Okay. No, don't do it again. Now do
Yes, sir.
it for y.
Okay, sir.
Find the displacement along the y direction.
Okay.
Okay, Ishan, did you get the answer?
Yes, sir. I got 10, sir.
10.
Yes, sir.
Okay, so let me check it.
Okay.
I'm getting here. I'm getting it here. Y displacement will be equals to u in the y direction is 3 multiply 2 plus 1 by 2 multiply acceleration in the y direction is being 2. Okay, so 2 times 2 squared. You can cancel this 2 and you get 6 plus 4, that is 10.
Yes, sir.
Okay, right. So have you
Sir,
understood this, how
yes,
it works now?
yes, sir.
See, the
I'm writing.
velocity along the,
I'm writing, sir.
this one or the previous one?
No, no, sir. Before one, sir. Yes.
The velocity along the x direction will affect the velocity along the x direction. The acceleration, velocity, displacement, everything along x will be affecting the x component only.
Sir, done, sir. I got it, sir.
Okay,
Yes.
so see what works here, that all the components they work separately. Okay, now if you want the to write the direction, you can write the direction also. If you want the component form, you can write it in the form of component also. So
Yes.
see, I told you the velocity can be written as 10 I cap plus 7 j cap, right? In the same way, you got the displacement along the x direction to be 12 and displacement along the y direction to be 10. So you can write
Yes,
it
sir.
as 10 I cap, 12 I cap plus 10 j cap.
Yes, sir.
Okay, let's try to do this question. After this, we'll move to the next topic.
Yes.
Let's see if you are able to do this. The velocity of a particle in xy plane at any time t is, the velocity is given like this. At t equals to 0, particle starts from the coordinates 2 meter, 4 meter, and find the acceleration of the particle at t equals to 1 second. Okay. So just do the part A.
Yes.
You need to find the acceleration at t equals to 1 second.
Okay, sir. Sir, can I use the first equation, sir?
Yeah, you can use the first equation.
Sir,
No, but how will you use the first equation?
sir, A, sir, acceleration.
Hmm? See,
Acceleration
you
of
are given no. See, the value or the function of velocity as a time is given to you as 2t I cap plus 3t squared j cap. Okay, this is meter per second. Now, if I want this to be acceleration, if I want acceleration from it, so I will differentiate it. If I differentiate it, I get here dv by dt, and since differentiation dv by dt is equal to acceleration, so
yes, sir.
will you try to differentiate it now?
Yes, sir.
Try to differentiate and obtain the formula for acceleration.
Yes, sir.
Okay, shall I tell you?
Yes, sir.
So see, if I differentiate it, I am making dv by dt. So on the right hand side also, I will write it as d by dt of, and let d by dt of 2t I cap plus 3t square j cap. Then this will be equal to, a will be equal to 2 times of dt by dt I cap plus 3 j cap write 3 j cap d by dt of t squared. And remember, you can't cancel this t and t. This is
Yes,
an
sir.
operation which we need to perform by the differentiation.
Okay.
So here, this dt and dt can cancel, or you can, even if you differentiate, you get 1. So here you have 2 I cap. Plus,
Yes, sir.
if I differentiate this, I get 3 is already there. If I differentiate this, I get 2t j cap. So my answer is 2 I cap plus 6t j cap as the velocity. Since we have to find as the acceleration, now we have to find the acceleration at t equals to 1 second. So to find the acceleration at t equals to 1 second, so if you find at t equals to 1 second, you get is 2 plus 6, and this should be equal to 8.
8. Yes,
8 meter per second square is the acceleration at t equals to 1 second. Okay,
yes, sir.
then you can try out the next one. Position vector and coordinates of the particle at t equals to 0. So see, now if you want to find the position vector of the particle, then you need to integrate it and obtain the equation for x. But that is a question from JEE level, so you can leave that. All right. Or if you want to try out, you can try out it.
Okay,
The
sir.
question is here. Next one is here.
So I'm writing, sir, that now.
Okay, you are writing the solution for that.
Yes, sir.
Okay. Apart from this, I'll be adding these three questions also as a homework part. You can
Okay.
do them. So this is the thing which we have got. And which book do you follow at your? Okay, you already sent that book, right?
Yes, sir.
Okay.
Sir, it's my college material, sir.
Okay, okay. You sent it.
Yes.
You can try out. Since you are preparing for this, you can try out this question.
Yes. Done, sir.
Okay. So let's see the question. I'm just adding this question so that you can do it. So these questions are for your homework and practice. You can do them as well.
Yes.
Okay. Now, so with this, uh, we'll start. Now we'll be starting with, right.
Yes,
So
sir.
I think you have understood about the motion in the plane.
Yes, sir. Understood.
Okay. So again, the questions, I think the questions regarding the graph and others you can do in the same way as we did about the motion in a straight line. Now we can do projectile motion. So our next topic here is projectile motion. So see how we define a projectile. Projectile is any particle or any substance which is only under the effect of gravity. So an object which moves only under the effect of gravity. An object which moves only under the effect of gravity is called a projectile. So we will have different types of projectile and we'll try to study them. So any object which is only under the effect of gravity is called as a projectile. So see, we'll
Yes.
see certain examples and we'll classify the projectile motion under three categories. Okay. So the very first category of the projectile motion is the vertical projectile. Then you have a horizontal projectile. You also have a oblique projectile. So here,
Yes, sir.
suppose if we have an object here and we throw it vertically upward, object is thrown vertically upward from here. We call this to be an oblique projectile. Okay. Since when it is in air, it is experiencing only the acceleration due to gravity. So this is an example of vertical projectile. It's moving upward.
Okay.
Okay. Even if
Yes.
you a free fall, if something falls so freely, so that is also an example of a vertical or free vertical projectile, as it is also under the effect of gravity. Okay, so the only force that acts over here is the gravity. So this is also a projectile. A vertical fall, a vertically thrown upward object, all of them, they are examples of vertical projectiles. Then we can have a horizontal projectile. Like suppose you stand over here on a building, and from this building you throw a ball or a substance horizontally. You kick a ball horizontally from here with a certain velocity. Suppose from here I throw a ball horizontally. Okay, so I kick or throw a ball like this in a horizontal direction. So this again, it will follow a trajectory, and this is again under the effect of gravity only. Right? So this
Yeah.
is which type of projectile is it?
Horizontal projectiles.
This is a horizontal projectile. In the
Yes.
same way, you have an oblique projectile. So
Yes.
oblique projectile is something like this. You have the axis, and suppose I throw an object from here. So from here, I throw an object at a certain angle theta. So from here, I throw it at a certain angle theta. Let's say it moves at an angle theta. So I made it throw at a certain angle with the x-axis. It's not thrown vertically, it's not thrown horizontally. It is
Yeah.
moving with a certain angle theta. So this is an example of an oblique projectile.
Yes, sir.
So
So,
this, yeah,
sir, it's a bit curved, sir. Like it's growing cross.
yeah, it's a growing curve. The object will follow a trajectory something like this.
Yes,
It will go like this, go up and then fall down. Like
yes,
in
sir.
this way it will go. So
And it
we'll
makes angle theta, sir.
how much?
Sir, it makes an angle theta.
Yeah, its initial velocity makes an angle theta with the horizontal axis.
Yes, sir.
So now we'll first discuss the vertical projectile. So for a projectile, vertical projectile, every time it depends on the directions that we choose. It depends on our initial and final points that we choose. Okay. For example, and if I choose here the vertically upward direction to be the positive direction and vertically downward direction to be the negative direction. So here I obtain every time I'll be taking my velocity. I will take my initial velocity to be positive. I will take my initial velocity u as positive. I will be taking my acceleration a, which will be equal to gravity, and it will be negative since it acts in the downward direction. The
Yes, sir.
acceleration acts in the downward direction, and we have chosen the downward direction to be the negative direction. Got it?
Yes, sir.
So here, when suppose you throw it vertically upward, so the ball reaches to a maximum height, and when it reaches to a maximum height, so at that point, at the highest point, the velocity of the ball becomes zero. If the initial velocity is something, so here its final velocity becomes zero. And
Yes.
you can use the kinematic equations of motion accordingly as we have used. Also, the time of ascent is equal to the time of descent. That is
Yes, sir. U
time
by G.
taken by the body to reach the maximum height. The time taken by the body to reach the maximum height and then
Yes.
falling will be the same.
Yes, sir.
And we'll discuss about the horizontal projectile also. So in the horizontal projectile, see, when it's moving horizontally, if you throw this object horizontally from this point, so you get it during its horizontal projection here. During the horizontal projection, we find its velocity along the x direction is ux, and its initial velocity in the y direction is 0. So I can say v uy, or initial velocity in the y direction, is 0, as I am not providing it any velocity in the y direction. Also, acceleration along the x direction is 0. Is there any force which is applying the acceleration in the horizontal direction?
No, sir.
No. So here, velocity along the x direction is ux, acceleration along the x direction is 0, and similarly I get the acceleration along the y direction. What will be the acceleration along the y direction?
Okay. Yes, yes, sir.
How much? Negative g.
Sir, it's also negative G. Okay. Why, sir, negative?
Yeah, because we are taking the vertical upward direction to be the positive. Okay. If you take the
Okay.
vertical downward direction to be the positive direction, suppose if I start taking the vertical downward direction to be the positive direction, then I will be considering this g to be positive.
Yes, sir.
Okay.
Yes, sir.
So let's concentrate on an oblique projectile now. Okay, just give me 1 minute. हाँ सर, बस बढ़िया है सर. हाँ, चल रही सर, क्लास चल रही थी. तो बाद में उसका प्रोग्राम आपका 10 बजे के आसपास तो फ्री होंगे. वही अब क्या उन्हें बता ही देता हूँ. कभी क्लास उन्होंने रखा है, 2-3 टीचर्स रखे हैं अभी. वही आप उस टाइम पे आ गए होते होते हो गया होता. चलिए एक दो जगह और देख रहा हूँ, आपको बता रहा हूँ. ठीक. Okay, so did you Ishan?
Yes,
Ishan?
sir. Yes,
Okay.
sir. I'm there.
Okay, so it seems you are getting everything whatever we are doing, right? Just
Yes,
try
sir.
to do questions. Questions are the ones which will help you. Yes. Yes, okay. So here we consider the object. Let us consider the object to be moving like this. Suppose it's moving with an initial velocity theta. So here, this is theta is the angle of the initial velocity u. And here you have the x-axis. So this is my y-axis. So the component of velocity along the x-axis, I can write it as ux, and this ux will be equal to u cos theta. The
Yes.
component of velocity along so uy along the y direction. So I'm making the component of this initial velocity along two directions. So had we studied how to make the component of a vector?
Yeah.
No?
No, sir.
Okay, so
No,
just
sir.
as an introduction I'm giving you, how can we make it? How can we make the component of a vector along two directions? So I say the resolution of vectors. Let us understand the resolution. Okay, so instead of doing that, let us start with the resolution also. It's a small topic, resolution of vector. So resolution of a vector, it means splitting the components of a vector along mutually perpendicular axis. So see, if we have any vector acting at a certain angle theta, like this, any vector can be broken into two components such that their sum should again be equal to the resultant vector. So here, okay, suppose I have a vector r. So this is my vector r, and I am breaking this vector r into two components. Suppose the vector r makes an angle theta with the x-axis, and here we have our y-axis. So I want to find out what component of r is acting along the x-axis and what component of r is acting along the y-axis.
Yes, sir.
Now the component of r along the x-axis, if I construct here a right angle triangle, so I can see that it has been divided in the x component will be equal to just the length OA, and the y component will be equal to AB. As I can write here the r squared to be equal to OA squared
Yes.
plus AB squared, right?
Yes, sir.
So if I want to break it into component, I'll be finding OA and AB. Okay.
Yes, sir.
So OA divided by R is equal to cos theta, right?
Yes, sir.
So OA by R is equal to cos theta, and hence I obtain OA is equal to R cos theta. And hence
Yes.
I can, in the same way, I can obtain AB to be equal to R sin theta.
Yes, sir.
Okay. So now AB is the y component and OA is the x component of this vector. Okay, Ishan, we'll continue in next class from here onwards. Okay, bye, Ishan.
Okay.